can you take like 5 minutes of time? Not now, I mean obviously at the end, and give me an overview of data profiling and analyst.
Yeah, I'll do that, Chandra.
Like that will be very good. I mean, I have a interview coming up actually, so just I need to know like what profiling techniques, what are the transformations and everything. So
Yeah, sure, I'll do that, Chandra.
if you just tell me, I mean, I'll quickly write down. I mean, 5 minutes is more than enough.
Yeah. Yeah,
That
I'll
will
do
be
that.
really
So
appreciated.
basic goal of this, yeah. So basic goal of this, what you call data quality is what to come up with good data, right? That's the main goal of what this data quality. To get there, we have what you call two major things that we do in order to get the qualified data. What are those two things? One is what we call profiling part. Second is what we call quality part. Yeah. So as part of this profiling, what we do here is within the data quality, we have two tools to do that. One is what we call Informatica analyst. Using that, we can carry out profiling part. Second is what within Informatica developer, we have data explorer part, which will be used in order to carry out profiling. Yeah, that's the first part of data quality. So as part of this profiling, what do? We are going to identify the strengths and weaknesses of a given input data, or the positive and negative points from a given input data, which will be done by using what profiling part. That is the first thing. Yeah. For example, like how many nulls we have, how much is the bad data we have, in terms of duplicacy, in terms of a range, in terms of metadata issues, all such things will be taken care by using what? Profiling. That's the first part of data quality. And second part of data quality is going to be what? Pure developer activities, where we are going to perform what? Parsing, standardization, enrichment, match and merge. Those activities will be carried out within the what we call data quality. So these are the two parts that we do within the what is called IDQ. Yeah, please go on a
Sima,
mute.
you said
Yes, Chandra.
Sima, you said in analyst also we do data profiling and explorer also we do data profiling.
Yes, we do on both the tools. Yes.
Or both the tools is used for data profiling.
Yeah.
Okay.
But the difference, you can ask question one, then what is the difference between this and that, right? In that anyway, I'll elaborate that. Yeah. So that's about what you call high level flow of data quality. Yeah?
So what is the difference? What is it? Can you
Or
tell me the difference?
I think now the topic will get deviated from actual flow. I think I can talk about that. I think others might not get this if they don't. Yeah. The difference here is, just let me put 2-3 bullet points. Analyst is a web-based client where we can carry out only column profiling and rule-based profiling. And Explorer is what we call thick client, which is standalone application, which will be used to carry out what uh, column profiling plus technical based profiling techniques, like we have primary key profiling, functional dependency profiling, plus join key analysis and foreign key analysis. All such technical based profiling things can be done by using data
So
explorer.
basically table profiling and cross table profiling is done by an analyst, right?
No, explorer.
Sorry, explorer, and column profiling is done in the
Yeah, column and
uh,
rule based.
column and rule based. Okay.
Right. Yeah, with this we'll stop here because I need to talk about many more things if we go on. At least I need to
Sure.
spend 30 to 40 minutes. Yeah? Fine.
Sure. Sorry about other folks. Sorry about that.
So fine. Now let's get into what we call the normal flow. So yesterday we have talked about like how to build a reference table from a scratch by using three ways. through which we could able to build what a reference data from a scratch. Yeah? So there is a one question before I get into what it call some more things. Raj asked one question related to what that population. This GoToMeeting has got some problem. Looks like it is not working like as it was with older version. Yeah, it's not good. Yeah, one sec, Raj. Let me. Oh, you want to speak? I can't unmute immediately. It's taking a lot of time. Yeah.
Yeah, basically my question was, the mapping which I created works
Yeah,
fine
others,
and all.
no, one second. Others, go on a mute. What is happening? Ramakrishna, especially, I think Ramakrishna system, where there is a lot of disturbance. Yeah, go ahead.
Yeah, I created a mapping like what you said, like till consolidation type, and I saw the data view and everything was fine, and I closed it today. I tried to open it. Before it opens the mapping, it trying to say an error occurred while.
Oh, identity populations, huh? Meaning
Yeah.
of that is what you don't have the population or reference data that has not been set up.
But I didn't ask to referring anything right in the mapping, like what you
No.
showed that.
That's correct. Which means while just opening a mapping where you are not only opening mapping, when you try to use match transformation, right, it expects what it called population to be available. So it will go and check the population data under DQ content. Under that you'll have identity population data. If you don't have it, you'll get that message box saying that no identity population or what is called available. So that's just a warning. We can just ignore that. We can still what is called create a mapping with what you call match transformation and start getting it configured. But you can't use identity matching, but we can use what field level matching over there. Raj?
Okay, can I create a sample identity mapping and put it there so that I don't get this error, or do I have to get it from somewhere from Informatica?
From Informatica you should get it.
Okay.
I think we would have seen it even in our environment also same. That is same very well. Yeah. Yeah. Fine. Any other questions? Hey, this GoToMeeting is not good. It's not that fast. It is very slow. What is mass transformation? Oh, I'll talk about that, Chandra, anyway. Mass transformation you missed, class Chandra? I think we talked about that.
Yes, I missed.
Oh, you missed it, huh?
Yeah, even me, Simha, I missed. I'm there for the initial class only.
Okay then. So then I'll cover that again.
Sima, just one question. When you right click on the mapping, right, there's a below validate, there is deploy. When I try to deploy, where does it actually deploy this mapping?
It will be under application server.
And as a maplet or?
No, as a service.
Oh, okay. Deploy to service. Deploy to file system. Okay.
As a service, as an application. There are two ways to deploy this data quality mappings. One, application. Second, as a service.
Okay.
Okay.
So,
Siva, can you show that once?
Yeah. Which one? I think I go with the flow. See, if random questions, right, I think we'll get deviated.
Deployment.
People will get confused. Yeah. If I start jumbling what is moving here and there, right, I'll cover all the things like whatever you're asking.
Sorry
Let's
about
go
that.
in structured way. Yeah. Others, right, normal other folks, right, who are new to this, right, they'll get confused. What are talking, right? So let's go the structured way. So because you guys asked question, I just started answering it. So then you guys have started continuing it, which is not a right way of doing it. Yeah. So because you guys already have got some exposure, right? I can do that. The problem is others, right? They'll get confused. Where are we, right? So let's not do that. Ask relevant questions like whichever topic we are in, right? Then it's beneficial for you and also for other participants, right? Yeah, randomly put questions, right? Then that's where confusion starts. So let's not do that. Yeah. That's what I thought. I explained that at the end of the session, but I thought let me just complete that. But you guys have started off continuing that. Yeah. Yeah. So now the next thing is what yesterday I was trying to show what how to create a reference table, right? Yeah, from a scratch by using flat file or by using what relational table. Yeah. So which is what we have discussed by using what unlist line, right? That's what we have done. So once we do that, the next thing is going to be what we need to know how to use that within the data quality. Yeah? So this is an unlist tool. Huh? Yeah? Yeah, so this is where we went in. Yeah, here we started off creating what reference tables. One, by using what you go from a scratch, where we have created the structure with the column name, column type, scale, precision, nullability, length, and so on, right? So that is what we have done as part of what you call reference table creation from a scratch. Yeah. And second, we have also what you call used a reference table manager interface where we have added a data for the metadata of what we have done as part of reference table editor by using what there is a add row, modify row, or delete row. You know, we have this environment, right, through which we could able to what is called create reference data, right? So that's what we have done. Then after that, we have also talked about next step. Can you see here? This is how the reference data would look like. Yeah. Likewise, we can add what we call any number of what are the records depending upon like what we could do over here. Yeah. So likewise you can add any number of rows. Let us say some number based on let us say silver customer tier, where you get let us say different probable representations. Yeah. Silver, let us say some spelling problem. Yeah. Such things also we should take care as part of building the reference data. Yeah. This part, as I said earlier, need to be taken care by whom? Analyst. So analyst job is what? To create a reference data, what you call, by using this reference table manager. Yeah. So which is what we do, yeah, as part of this particular reference table manager. Yeah. So now once we do that, in case if you want to make any modifications and select any row and start selection of this particular edit button and then perform any changes, which we call modification of existing data. Yeah? And in case if you want to modify the structure, select edit table through which we can edit the existing what metadata or structure. And if you want to perform bulk operation like a find and replace, we could do that by using this. Yeah? Find what and replace with what. Yeah? This also I think I have explained. Here we can do it interactive way, which means one by one. And then second option is what? We can also perform bulk, which means wherever it is going to match, all of them would get replaced. Yeah? So these are the what you call different options. And finally we have delete button, which is the last button. We can select one or more rows by using check boxes and start getting them deleted. And once you do such operations, so all the changes of what is being done against with the metadata or with the data, all of them will be tracked by using what? This particular audit trail. Remember, this is one of the good features of what we have in this particular what reference table manager interface, where we can keep track of what we call who has modified, deleted or created, or all of these operations can be done against with metadata or against with what we call data. Yeah? So that's what we have discussed. Yeah? Now after that we can also talk about what we call like how are we going to do it by using what we call other way, which is what we call the second option, which is going to be what how to create this reference table by using what flat file. That's what the second example which we discussed. What we discussed over there, we have just imported flat file data through which we could able to create reference data from a scratch. Yeah? So this is the second option that we have used in order to create what we call metadata as well as data, which means what as part of import, what is it going to do? It is going to what we call import the header part that we have in the flat file, consider that as what we call field attributes and corresponding type. Flat file means normally most all of them will be string, and then corresponding data. Anyway, you will get it from a flat file. Through that, we can import it here. There is a question from Siva, previous videos. Yeah, you will get that Siva. And second, do you need underlying physical table to store this? Yeah, yes, Siva. So what it does is you will have all these things, right? Like a reference table data. This will be stored in a model repository. So model repository is a place where we are going to store all this what we call a reference table information. Yeah? That's what happens. Yeah? As such, we don't specify what the physical or we just specify the name of this reference table. So against with that name, it will be stored in the model repository. Yeah, I'm just unmuting. Yeah, you can shoot out. The go-to-meeting is yeah. Go ahead. Sai, you have a question, right? Go ahead, Sai.
No, what is the question, Simha? You are answering the previous question.
Chandra, I think Sai was asking a question. Sai?
No, what is the previous question you are answering?
The question was, is it going to store an underlying physical table? Do we need any underlying physical table to store this? By default, it is going to create a physical table like reference ref table underscore flat file. It is going to create a table with that particular name. Underneath, you will have the data stored, like whatever data that you put in the preview. That's what I was answering, Sai. Clear side? The question was, where does it get stored?
Yeah,
What is
thanks.
the
I
physical?
understand.
Yeah,
I
physical
got you.
table is this, the name that you can see in the tab, like a ref underscore table underscore flat file. That is a physical table side. Yeah. Any other questions?
Sima, when this table, this is a physical table in the some database or something, right?
Yes, you are right. That's we have model repositories. We have different what do you call database connections we create, right, at the time of model repository service creation, and at the time of profiling database, and at the time of what you call staging, right. So out of them, it is going to make use of model repository connection where this table will be created and its data will be populated in the okay? But you cannot
But real
find a
time,
query.
Sima,
Yeah.
but real time, if we actually, this is a small file that you have loaded, but if it's a huge million data files we usually get, so if we were to load it in this way, won't it take a lot of table space
No,
or
you
something?
don't get that. See, reference data will be very small. You will not get millions of records in reference data. Yeah? Like I think you guys would have seen in the lookup concept, right? There are two parts, right? Source data and lookup data. Have you ever seen the case where getting 1 billion records in lookup table? Rarely. Rarely. I would say 99.99% you will not get it. Yeah, that is why it's similar to what I call what we do in reference table. Yeah, it's very
We would put the static data in the reference table, that's what
yeah.
you're talking about?
Static means for today's business, let's say it will be static, or for this particular week's business, it will be static Chandra. But after that, if there is any change required, they can just open it and change it. Now it will be mostly it will be static only. But if you want to change, you can change it.
Okay.
Yeah. So data will be very small.
Okay.
Reference. Just remember. I think you guys would have used lookup like anything, right? Lookup table data will be very small.
Right.
Not in terms of billions or millions. Yeah. Thousands of records will be there.
Yeah.
That's also very high.
Correct.
Maybe hundreds of records. That's the most widely used practice, right? Okay.
Correct.
Yeah. Fine. Now, so let's get into what we call other way to create reference table, which is what countries, which is a table, right? So what we did was we have just created a reference table based on what? Relational table. So import what you call definition from relational table and start getting the data onto this what reference table manager environment. Once you do that, if you want to perform any changes, you could always do that. Yeah? So this is what we have discussed. Plus, we also have what we call other features. Like we have, how are we going to create a profile? Just now, I think Chandra was trying to ask question. So one question, right? Profiling part in the context of analyst and explorer. Yeah? Here, in order to what we call perform profiling here, what do we need to do? We need to create what? First, physical data object. How do we do that? We do that by using this new flat file and then import a flat file like wherever you have it, like for example LA customers or whatever, and get the flat file imported onto this and get into next. In case if you have file in the network environment, right, this means the physical file should have been placed in some other remote system. In that case, we can use enter a network path through which we can obtain the data from that particular flat file. Yeah. And then once we do that, supply all these basic things like what you guys would have done in the Power Center also, like what? Supplying the delimiters and then selection of what you call import or treat first line in a given input data as a header, and then start what you call getting the data imported and also header imported onto this particular what you call environment, where we are going to create a data object as a result of these operations. Yeah? So let it get executed. It is similar to like what we have done in the Informatica developer as part of physical data object creation. Here also we do the same thing, right? Now click on next. Now can you see here, top portion or first pane or top pane belongs to what preview of data, and last or bottom pane has got what columns, yeah, and corresponding types. And get into next and start supplying what I call data object name. In case if you already have this data object which is already created, you will get errors saying that data object already exists. By default, this data object name will be equivalent of whatever the file name that we get. But if you want to change it, we can always change it, like what we have done now, and supply project and folder where we could store this particular data object. Yeah. Now click on finish. As a result of that, it is going to create a data object, which means what in simple terms, table definition. That's it. So once we have it, we can read the data from the source, like whatever file that we supplied, and start discovering it, which means what, start carrying out analysis. So as part of analysis, what do? We are going to analyze what is called metadata and also data. Both of them would be accomplished as part of what is the profiling or analysis. Now, once we have done this, can you see here, there is a LA customers temp data object has been created under data objects category, right? Once we do that, we can get it open and start what we call viewing the metadata. After that, what we need to do here is we need to start configuring profiling part. As part of this profiling configuration, we can identify what we call, we can configure like how many number of rows or how many number of columns that we need to take them as input in order to carry out what, profiling. Yeah, fine. So this is what we call preview part. Then once you get that, on the right side you can see actions button, where you can see new submenu and submenu item, which we call profile. Select that, which means what, in order to understand the data, we need to use this profiling feature, where we need to configure the relevant columns and the number of rows that you want to analyze. Based on that, we can start understanding the kind of data that we have from the source. Yeah? By default, we separate the what is called data object name as LA customers underscore temp, right? Profile underscore will be prefixed. But if you want to change, or if you want to what is called use your own name, we can also do that. Yeah? And store this particular profile data object under the profile category. We'll see that. Yeah? Now click on next. Yeah, can you see here on the left side we have the columns. So we can select like what columns that we are going to use in order to carry out profiling, and on the right side we can select how many number of rows that you want to use in order to carry out profiling. Yeah. So first, our default profiling technique that we use here is what? All the columns and all the rows. I repeat, by default we call that as a quick profiling or default profiling. What do we have? We are going to carry out analysis for all the columns which are what we call selected on the left side, all the rows which is highlighted on the right side, which means what? This is what we call quick profiling. By default, this is the two options that you could see here. Now we can get it set. Yeah? This is the simple or default configuration that we use in order to what we call configure this profiling part. Yeah? Once we configure this profiling part, next thing is what? we need to start getting this profiling executed. Once you execute this profiling, you could able to see the results that we are going to talk now, where we have nullability, metadata issues, and duplicacies, and so on. I'll talk about those properties. I think I've said that as part of developer client, where we have used Explorer, right? But here also we will do the same. Only thing is, this is based on what I call web-based, but Explorer or within developer, it is going to be what I call the standalone application. That's it. Now we can see what I call on the left side all the columns and corresponding attributes, like in terms of unique values, unique percentage, nullability, null percentage, data type, which is info data type percentage, and then document data type. Minimum value, maximum value, last update date, last profile date, and then drill down. So which means these are the what I call summary properties. Anyway, I'll talk about each and everything with example. And on the right side, we can see detailed properties in terms of values, patterns, and statistics, right? Which is what you can see here, right? Now, let us start getting this particular profile data object executed, so that so far we have just configured, but we did not execute it. Now, to execute it, you can just run on this profiling window and then say run profile. Here you can select, in case of runtime, if you want to select the specific columns on corresponding rows, we could do that. If you want to do it for all, just click on run button. So it is going to execute this profiling for all the rows and for all the columns, which is what we are going to look at now. Yeah? As a result of this profiling, what we are going to analyze here, unique values, unique percentage, null values, null percentage, and then info data type, documented data type, info percentage, and then minimum value, maximum value, and then last profile date for each column, and then drill down. If you want, drill down concept need to be enabled for each column. That is on the summary properties. And detailed properties, we'll talk about values, patterns, and statistics. So those things we are going to talk about them with what? Each column. This is what we call column profiling, right? For each column, we are going to do such operations. So let it come up so that we'll talk about them. I've shown this by using developer client, but now I'm showing it by using what analyst client, that's all. But the results will be same as like whatever was discussed with the developer client. Yeah. Can you see here? Now on the left side we can see all the columns, yeah, and corresponding values that have been populated. Yeah. So what it does as part of profiling, it is going to take this LA customers platform data object and start getting the unique values, unique percentage, null values, null percentage. Let us take one example and start understanding from a scratch, like whatever we have discussed within what developer, right? Same thing, we could do that over here also. Yeah. So first and foremost thing is what we have. How many unique values we have? There are 12 unique values. What are those? On the right side you can see values, right? Where we can see what are those 12 values that we have in this what we call unique part. Yeah. Similarly, we can talk about what we call unique percentage. Meaning what? Like how much is the percentage of duplicacy, or how much is the percentage of unique records of what we have from a given source system. That's where this unique percentage summary property is going to help us. Yeah? Where we have what, how much? 2.4 percentage. So how do you derive that? It will be derived based on what? Number of unique values divided by total number of rows. So how many total number of rows we have? Total number of rows are what? 500 rows here. So which means what? 12 divided by 500 into 100 is equal to what? Percentage of uniqueness, which is what? 2.4 over here. Yeah? 12 divided by 500 into 100, right? There are 500 unique values, right? Now, the next is what? Null data. So we can see like how many records where there is a null. So we have 28 rows where there is a null. So why do we need this? We need these values in order to what we call understand, or in order to what we call, okay, these are the what we call, this kind of duplicacy of data we have, and this kind of what we call unique what we call null data that we have. Then we can take this as a base to take a call whether we need to proceed further or not. So this is going to be the starting point before we get into or before we carry out any data quality operation. Remember, so without this, if you do that, then blindly will be doing something, but without what is understanding the kind of data that we got from the source system. Yeah? So there are 28 rows, but in case the business doesn't expect, let us say, they doesn't expect any nulls. In that case, we need to what we call start analyzing it. What are those records where there is a what we call nullability? To do that, there is a drill down. Can you see here? Down arrow button on the right side. We can just click on that so that we could see what are those records where there is a null data. Then what analyst does is they are going to look at those records and start what we call taking a call, like what to be done for such records. Yeah? So that is where, can you see here, all the records where there is a null. So they could look at who is that customer and what are the other what we call column values. Based on that, they can take a call, like what to be done with these customers. Yeah? Now, the percentage is very straightforward, which will be derived from this particular total number of values where we have nulls. So 28 records where there is a null out of 500 rows. So you can just calculate percentage of nullability based on what? 28 divided by 500 into 100, which is equal to what? 5.6. Yeah? So this is what we have, or this is what we do as part of null percentage calculation. Yeah? Now the next, which is going to be the important thing, which is what? Data type. There are two types of data types. One is what we call documented data type, meaning what? It is the type that we are going to create from the source, or it is the type that we create while importing the definition from a flat file or from relational table or whatever. Yeah? So which is what we call documented data type. In this case, you can see what? String with a length of 15. Yes or no? Yeah? That is the what we call documented data type. On the left side, where we have string 10, right? It is an inferred data type, which means what? It is the type that would be created when by traversing through all the records and start generation of actual type that is required in order to read most of the records, not all the records. Remember, most of the records means what? More than 95% of records. In case if you want to read that much of percentage of records, then we use what we call infer data type. Meaning what? It is going to take majority of the records where there is a similarity with respect to number of characters, with respect to type. Yeah? These two things will be taken as input while formation of what we call infer data type. In this case, we have what? String 10. If you look at this data on the right side, these are the unique values, right? Which means what? Do we see any value where we have more than 10 characters? No. Answer is no. Diamond 1, 2, 3, which is a longer string value that we have, right? So which is maximum 10. So that will be taken as a base, majority actually, not only this, majority of the records which is going to be taken as a base. Based on that, this particular type will be created by this particular tool which we call infer data type. Now there is an inferred percentage. Inferred percentage will be derived based on what? Based on the total number of what we call records that can be fit onto this particular inferred type, which means what? Now we specified diamonds, what is a string 10. Can we fit all the records like diamond, ruby, emerald, bronze, 2, take what we call diamond 1. If yes, inferred percentage is 100. If no, inferred percentage will be less than 100. Remember, I repeat, if you could able to fit all the records of what you could see, yeah, on the right side values, right, against with this particular type, which is string 10, then inferred percentage will be 100. In case of any deviation, which means what? In case if one or more of these records cannot be fit with this within that particular type and size, then you will have different inferred percentage, which is a variation we call in simple terms. Variation against with what we call actual. So which is what will be done as part of calculation of inferred percentage. Yeah. Now the next is what we have, minimum value and maximum value. Can you see here? So minimum value is what? It is the minimum value from n number of unique values. Can you see here? We have 12 unique values, right? Out of them, minimum value is what? 1. And maximum is what? Silver. On what basis we are going to derive these values? Just what we call apply or order the data based on a descending order. Once you do that, top value, which will be considered as what we call maximum, and bottommost will be considered as a minimum. Yeah? So that's what will be done while calculation of min and max. From this, what do you infer? We will get to know the range of data that we have from a given source system. I repeat, from this we would get to know the range of data that we have from a given source system. Okay, this is the upper limit, this is a lower limit. Within that we have the data for today's business or for this particular week's business. That will be identified by using what we call range or domain or min and max, all are synonyms. Now the next is what we have, last profile date and time, which will be used in order to see like when this particular column was profiled with respect to date and time. Remember, why do you need to have this particular attribute? We have to have this attribute because let us say for today's business, you would have carried out profiling for first 4 columns. It doesn't mean that we are going to apply profiling 4 columns throughout the lifetime, right? For tomorrow's business, what we call, things would have been changed. So instead of 4 columns, it could be what we call 8 columns or 10 columns. In that case, date and time for the 4 columns will be different from other columns. So in such case, for each column, this particular last profile date and time is required. Yeah. So then finally we have what? Drill down, which is going to help us in order to get deeper insights to all the unique record, all the duplicate records or all the unique records. Yeah. So all the unique records you can say. Yeah. For example, if we enable the drill down for this particular column, then we can see what? We can get all the details of each record, which means what? On the right side, you can see down arrow button, right, which is a drill down, which means what? There are what we call diamonds. There are diamond values with a frequency of what? 116, which means what? There are 116 records where there is a diamond. In case if you want to know what are those records, then we have to have this drill down enabled. Then only we could get the details of each what we call value, which is what we call 116 records. All the records can be seen and see whether those records as per our expectation. Yeah, so this is what we have as part of what we call summary properties of what we have as part of this column profiling. Yeah. Just to enable, what is the purpose of drill down checkbox? To answer that question, in order to get what we call all the details of these occurrences or unique values or duplicate values, for that we use what? Enabling drill down. If we don't do that, we cannot make use of this down arrow button to make it very simple in this context. Okay, then the next is what? So we need to talk about detailed properties of what we could see on the right side. So one of them I was trying to talk, which is what we call values, where we have all the unique values, and for each unique value, how many occurrences of we have in a given input data. So 116 for diamond, and 93 records for ruby, emerald 70, and null 28, and so on. Yeah. So you'll get what you call, okay, this much of occurrence of records we have for each value. Then we can see what percentage of occurrence, which means what percentage will be derived based on frequency and total number of records. For that, based on that, we are going to get percentage. For example, in this case 70, right? If you take emerald, so percentage, how do you calculate? 70 divided by total number of rows, which is 500 into 100, which is equal to what? 14%. So total rows which we are using here is what? 500. Yeah. And to calculate a percentage, we can use what is called occurrence or total number of records, where there is an emerald value divided by total number of rows, which is 500 into 100, which is 14. And if you want to see what are those 70 rows, then drill down should have been enabled. Then only we can get the drill down information. So that is what we do as part of what? Column profiling output. Yeah? Any questions here? In column profiling part, with respect to what? Summary properties we discussed, plus I was also trying to explain what we call detailed properties. One of the detailed properties, which is values, where we talked about unique value, frequency for each unique value, and then percentage of occurrence, and then chart. Chart is anyway that will be derived from the percentage, just like filling a grid with a percentage. Yeah. So that's what we have discussed as part of this. Yeah. So we will extend this from here on tomorrow's session. Yeah. So that we will get into data quality stuff. So profiling part normally would not be done by the developers. Yeah. So if the developers are doing profiling, means what? Then there's something wrong with the organization. Yeah. So normally developers should not do this. Yeah. It's a job of analyst, but they need to have good knowledge and data and the business. So they are the right people who can take a decision after looking at this data. Yeah. Okay, reference table part is done, Srinivas. I've already explained that. Srinivas? Yesterday I think we have done that, right? Yeah. So there is a question, please let me know the installation procedures and document. Yeah, I'll do that, Siva. So we have not done setup actually. So we need to do that. So today some people have joined late, right? So that's why we didn't focus on that much. So we'll do that tomorrow's session. Yeah? I think download part, I think you guys have done it. But I'll drop an email like how to download, the step that we need to follow while download. Yeah, fine. Okay then. Thank you very much to IDQ Wise. Yeah. Now we need to start MDM part. Yeah? Take care of this what? Capturing rejected records in what we call separate table, which means whichever is not matched against the source system data, those records will be taken care or will be kept as part of separate table, which we call reject table, right? Now this is a source, right? We just defined 2 columns and default number of rows. Yeah? Now let us start defining what we call other columns. Yeah? let's say other columns in this reference table. So C1, which is going to be the key column, that should get matched. One of the columns should have matched with what I call source data column, source column, whatever. Let's say other column is what C3, which means for a given C1 value, you can get C3 value, which means state code, let us say C1, state name, let us say C3. Yeah. C1 is going to get matched, you will get corresponding C3 value. That's it. And then configure it in lookup. So lookup configuration, what do we need to do here is primary key of one table, which is a source, should become a foreign key to this. Yeah? Connect this. That's it. This is how we build a connection between what source, which is a source link, which is a link 4, with reference link, which is link 5 or whatever. Now you will get the C1 data from source and C3, because wherever there is a match, get me the corresponding lookup value. That's it. Over. This is what we do. Depending upon the failure option that I did not show, I'll show it now. So here you'll have what conditions in the sub menu, where we can start configuring what we call different failure options here. Can you see here? Last, I was trying to talk about these options, right? If you say drop, only matching records will be sent to a target, which is what I call the normal output, which is sequential fault in this case. Let us start getting this job saved. And define this, provide a job name, lookup underscore sequential file. Yeah, actually it should have not used file, because here we need to supply let us start supplying a sequential file. So need to waste time here. Peak is the easiest part. Output and sequential with what I call lookup, the drop output, right? And then that's it. Now say okay. Yeah, that's it. Now save, compile and run. So you'll get only matching records. So all the 10 records, right? So 0 to 9, because we have used default values, right? So 0 to 9 you will have it in reference table and also in the source table. So all of them will get matched. Yeah? That you will see as part of this output. So okay, where is this? Yeah. So here you can see that all 0 to 9. This is straightforward. But if you change what you call data, right, then you can see the difference. So let us change the algorithm and then you can see the difference. Let's say starting value is 8. Yeah? Then 8, 9, 10, 11, 12. Only 2 records will have what I call match. Yeah? So then rest of them, there will be what I call dropped. That's what is a drop, right? So whichever is not going to get matched, so those records should get dropped. Yeah? So, but we have not changed the what is called target file name. So we are going to use same target file in this particular example. Yeah. Yeah, there are only two rows, right? Because only two rows get matched. Because we started with 8, right? 8, 9 will get matched. The rest of them will not get matched. So they'll be dropped. Yeah. So that's what happens with a drop option. But if you want to capture this rejected records, which means the records which does not satisfy what is called the reference table, how are we going to capture the rejected records? To do that, we need to use a condition, which is a lookup value condition, which is going to be what? Reject. Then say OK and OK. Then we need to use one more target, which is going to be, let's say we use sequential file only because we are using file. So let's capture rejected part in a reject table, which is what is this? So seq underscore reject dot txt. I'll put lookup here. Fine. Say OK. That's it. This important stage. So remember, lookup, join, merge, null. These are the very important stages. Plus transform and modify stage. Rest of them are minor things. Yeah, can you see here? 8 rows which are rejected, which you can see as part of what is called rejected file. So 8 rows, right? Which means 0, 2, 7. I think 1 is correct. Can you see here? 10 to 17. 8, 9 matching, right? So 10 to 17, they are not going to get matched. Which is what? This is source data, right? The source data will be transferred target, which is 10 to 17. So that's it. Because we started our algorithm starts with what? 8. Yeah? That's it. 8, 9 will match with the reference table. From 10 to 17, they are not going to get. That is why these records are rejected. Yeah? Clear? So that's about what we call capturing rejected part. Yeah? So similarly, you can try other options, which is straightforward. So continue means what? Though the records are not going to get matched, but still records will be transferred to a target, irrespective of whether they are going to get matched or not. Yeah, which is equivalent to left outer join, yeah, which is what we call continue option within this lookup. So in that case, we should remove this reject part. We will have only one output link, which is going to be the stream output link. Yeah. So here we can select what in conditions it is going to be the what continue. Yeah. That's it. Now save. And run. That's it. Can you see here? All the 10 rows have been transferred. Now if you go and look at here, you'll have all the rows like 8, 9, 10, 11, 12, all that. Can you see here? All the rows. But wherever there is an unmatched, lookup value is going to be what? 0. This is equal to what? Left outer join in join stage, which we discussed, right? So this is what happens with the continue option of this lookup. Wherever there is a match, you will get the corresponding lookup value, which is 8 and 9, and 10 to 17 where there is no match. So reference table data, we don't have it, so you will have 0. Yeah. So this is what happens in this. Yeah? Similarly, you can try fail option, which is what if one of the record is not going to get matched, job would get failed. Not possible. So this is which means what in this case job should get failed because only 2 records where there is a match, right? Rest of them there is no match. So job will get failed. Yeah? So that's what you will see anyway. So that's about lookup part. On top of that, we have sparse lookup and normal lookup. When to go for sparse, when to go for normal. Oh, how come? Oh, I didn't change this lookup condition, right? That I need to change. So yeah, this is anyway straightforward. So there are different types of lookups: sparse lookup, normal lookup. The one that we have done so far is what? Normal lookup, where there are lesser number of records in the reference table, more number of records in source. But if we have other way, so which means what? We need to use what is sparse lookup, where if we have more number of records in reference than compared to source, then we need to think of using what I call sparse lookup. Plus, we also have within a lookup, if we want to sort and perform uniqueness, we can also do that by using what I call in stage or in or link sort of what you could see in stage properties. To do that, we can configure or we can get into what I call inputs and then go to partitioning and select what I call hash. Yeah? And if you want to apply what I call hash key, which is C1, and perform sort, remove the duplicates and focus only on unique values while performing a lookup, we could do that by using this. That is where what I call hash partitioning method usage is needed. Without hash, we cannot perform that uniqueness for. In case if you want to perform only unique records lookup. Can you see here? Under link, we call link sort or in-stage sort, which means what? Link level, there is a sort symbol, you can see red sort icon, which indicates what? We are performing a sort in link level and start applying a lookup. So sorted data will be taken as input to the lookup and start performing a lookup. After that, data would be transferred to a target. So these are the what we call different options of what we have in lookup. Plus, we also have lookup condition. We can also define condition. So before lookup value, right? So based on that also, which means within this particular range of data only we need to perform lookup. Then start performing lookup based on the condition. Yeah, that's the other option. I think I have already explained that. Now, the next is what, which stage is left over? Pivot. Pivot enterprise may be missing. I think pivot stage I would have covered that. Yeah. But then I will cover both. So it's very simple. Pivot stage, which is a horizontal pivot we call, which will be used in order to convert what I call the number of or columns to rows. Yeah? Which means what, let us say you have monthly sales, yeah? Like January, February, March and so on, 10 month sales, right? Now you want to what you call convert n number of months, which is 12 months, a 12-month sales data to a single output, which is a month, where we are going to capture what we call all the rows plus apply any aggregation on top of that. In such cases, we use what I call horizontal pivot, where we can convert n number of columns to what I call rows. So, which is what will be done with horizontal pivot. Let us start defining columns, assuming that first column belongs to what? January month. Second column belongs to what? February month. And third column belongs to what? March column. Now, once we do that, these are what are the columns, right? Without pivot, you transfer the data. For each column, you have 10 rows, right? Yes or no? Now, if you want to what you call convert all the 3 column data to 1 month, which can be done by using what you call pivot. So, which means that is from syntax perspective. So, we need to get into outputs tab, where we can say month column and derive from n number of columns. N is what? Here 3 columns. That's it. And start storing output of this into this particular type, which is integer. Now save it, get the data transferred to a term, which is horizontal so that's it. Yeah. Or we can also say output of this to what do you call file, because this will be used for another pivot stage. So let's get into the file. So pivot output, right? That's it. Yeah. Can you see here there are 10 input rows and 30 output rows. Yeah. So which means what there is error here. Let us see the error. Pivot. Yeah. You can see in the preview anyway. Yeah. No. So what is the error? Anybody read this? I can't read clearly. From my side, monitor phone is there. Let's close this. What is this error? Unable to open. Okay, it's a file problem. It's not pivot file problem. Let's look at it. Because I can't. Yeah, C colon. Yeah. Is it right now, Anis? I don't know. I can't read clearly because the resolution is very bad from my side. Let's see. Yeah, now it's fine. Can you see here? 10 rows input, right? 3 columns, 10 into 3, 30 rows have been transferred to sequential file. That's it. Yeah. Which means what? With this, we are converting what columns to rows. Can you see here? There are 30 rows, 0, 0, 0, 0, 1, 1, 1, till you will have 9. So 10 into 3, 30 rows. So that's about horizontal pivot part. It's very simple. Now the next is what? Let us say you want to do it reverse way, which means what? Convert this rows data to columns. How do you do that? I'll say here pivot input. Yeah, now let us change the value here. Let's say we have, I'll just delete what double quotes to empty. Yeah, I'm just removing quotes. Yeah. Now let us start defining what I call other column values, which is how are we going to group these records, grouping values. Yeah. Let us say 3 and 4, 7, 7, yeah, and 1. Let us say 44, 55, 66 or whatever. So assuming that we have data like this, now we need to what I call convert n number of rows to n number of unique values or duplicate values to columns. 0, 0, 0 means what? C1 0, C2 0, C3 0. Like this, it should be stored in separate what I call columns based on grouping key. So to do that, we have or we use what I call vertical pivot. Yeah. Convert rows to columns is what we call vertical pivoting. Yeah. So now let us start building a new job where we can start using that sequential file, yeah, and then get into what pivot enterprise and then store the output to a file or whatever. It could be a big account rate, so let me use file. So now we need to use what pivot input. Browse to a location where you have this particular file, which is pivot out. Is it pivot out or input? I think I'll yeah, probably can type here and is pivot input. I can select pivot input, right? Let me type it. Yeah, say okay. Yeah. Yeah, define a job name here. Okay. Yeah, hopefully it is fine. I'm just typing it because I can't read properly because of resolution issue from my side. So now define the pivot properties. Oh God. Let me do it now. These are the stage, right? Okay, define without reading properly. So let us say, which is what we call we define columns. One column, let us say C1 column, which is of type integer, and then length, forget about it, and this is going to be the group by. Or one column should be made as what okay, group by, other column should be made as what pivoting column. Here we can do both horizontal and vertical. We need to change it to vertical here. That was a problem, we are getting error. Now let's go to this guy. Go to pivot properties. Yeah, here we need to define. So let's say C1 column, which is of type integer, and then let's say one column we are making as a group by, which is first column, right? 0, 0, 0, 1, 1, 1, all that. Yeah. Now the next is what some other column, which is a group by column, which is again, let's say integer, whatever. This is going to pivot column, which means tilt. Array size, how many number of similar values that you want to, what you call group. Let's say 2 example, which means what? If we have two similar values, it will be converted to columns, C1, C2 like that, C1 underscore 1, C2 underscore 1, and so on. Yeah? So that's what we need to do here. Yeah? Oh, file name still wrong, huh? Let's see. And then if you want to use indexing for faster processing, arrange is optional. Sorry, let me try to define columns. Yeah? And then how many columns we have? C1, C2, right? Okay, then define this and let's see. The file name is wrong. Let me see it. Yeah, that's wrong. Okay, I'll do one thing. This is a file name. Service. I'll just copy this. Yeah, go to properties. Oh, it's not .txt, I think. C colon output slash this. Let's say that one. Oh, what is happening? Yeah, that's fine now. So we could able to use the data. This is right now. And now, once we have it, we could able to use, right? Which means what file name, all that is right. Now, compile and run. Oh, what is this? Empty. How come it's not able to read? We have records, so we could able to read. What error we got? Let's see. Error property file to sequential file, but which is empty. Oh, I think let me log on from other system. I can't read at all. Can someone fix this? It's asking for this, huh? Can't read that properly. Error. I will log in from other system just in 1 minute. Oh, this is output, right? Okay, thanks, man. Okay, fine. So vertical pivot, right? Vertical underscore pivot dot txt. Fine. Yeah, now you can see, right? There are some rows, I can't see the count here properly. So it has been converted to what we call columns. Yeah? So let's try to open this file. What was that? Vertical pivot. I think so. Yeah. Just guessing. So let's look at it. I think this is the first file. Should be. Yeah. Can you see here? We have what we call grouping is what? 0. Array size is what? 2, right? Which means what? Split that into 2. So we have first is what? 3. Second is what? 4. This I can read clearly. So input also we need to open so that we can compare. Yeah. Can you see here? 0, 0, 0. Array size is how much? 2, right? Which means 2 records. Yeah, you'll have 2 here. That is perfect. Now 3, 4. From where you got 3, 4? Which means what? The column row data, right? 3 in first row and 4 in second row. It has been converted to what? Separate columns, which is 3, 4. Yeah. And other is what? Next row, which is what you call 1, 1. Which is what? 1 is how much? 44. This is 44. And next row is what? 55. It has been converted to column. Yes or no? So that's what happened. Which means what? There are 2 occurrences here. Yeah? So which is here, in this case, we are leftover thing is only 1. This is just what we call the number of occurrences, you can say, or indexing, not indexing, occurrences. Now similarly, in 2, how many we have? We have only 1, which is 99, and second is what? Which is 0, which means what? We don't have any similar records. So if you don't have it, you will have what you call value 0. So that's what happens with what you call vertical pivot, converting rows to columns, which means what? Based on this array size. Array size what we define? 2, right? So that is why only it will be converted to 2 duplicate rows to 2 separate columns. That's it. So depending upon group by height, you will have, if you have similar records, you will have corresponding number of columns based on the array size. That's it. Let's go and look at what will change the array size. Just correct me the number, what I am going to define. So this is, let us say, if I say 3. Yeah? If I define 3 array size, then 3 is correct, right? Now we can start compiling. This means what? If we have 3 duplicate values, all of them will be converted to 3 columns. Yeah? That's it. Converting rows to columns based on a group of similar records. That's all it does. Yeah? That's quite opposite to horizontal pivot. Oh, it got failed. Yeah? So that reason for failure, so you guys need to tell me a message so that you can see. Which pivot is this? Yeah, first one, right? I think is sorted. What is the error here? Unrecognized argument pivot. Unrecognized argument pivot index. So index value is wrong, I think, right? Is that correct message? Hopefully yes. What is the value? We have 3 here. Okay. But grouping records, how many we have? Yeah. Now we can see it, right? So now I don't know what input goes how many, I can't read. Output I can't read. Now anyway, we can see there should be 3 columns now. That is a goal here, right? So that you will see now. Yeah, can you see here? Group of 3 similar records, 3, 4, 77. Yeah? Which means what? Array size is 3, right? Which means what? 3 similar records will be converted to columns based on what? This is a pivot column, right? It's a second column, 3, 4, 77. first column, second column, third column, which means converting 3 similar rows to what we call columns is what we do in pivot. Yeah? Similarly, for the second row is what? 1, 1, 1, 44, 55, 66. These are the pivot columns, right? All of them have been converted to what we call column. Similarly, for the value 2, where we have only 1, right? Other things are not applicable, so that's why they are 0. So rest of the records like a 3, 4, 5, whatever, right? For such records where we don't have what we call pivot values at all, so that's why we can't see any other data here. That's what we do here, and we can have what we call columns also. If you want to define your own columns, we can do that, or else just enable what we call first line as header or whatever, right? Then you will get that when column ends C1 underscore 1 or whatever. So randomly it is going to generate some names. So this is what we do in what we call pivot. Clear? Any questions or confusion here today? Some things I could not able to read, so there are great mistakes, but functionally I think it is a word, right? Like what we do in this pivot. That's you can see here C1, C2 and C2 underscore 1, C2 underscore 2. So which means what? Second pivot column has been converted to what we call rows to columns, which is 3, 4, 7 decimal. Each value should be stored in separate column, right? That anyway random it's going to generate, or else if you want to explicitly create columns based on array size, we can also create it, your own meaningful names. So this is what we do in vertical pivot. So that's about what I call vertical pivot part. Any questions over here? So that's it. With this I think rest of the stages I have already covered. So that's all about with respect to stages part. If you have any questions, please let me know so that we can plan for 1 or 2 sessions and we close that.